హాయ్ స్టూడెంట్స్, వెల్కమ్ టు ఏస్ ఆన్లైన్ ప్లాట్ఫామ్. ఇక్కడ EAPCET 2025కి ఏస్ ఆన్లైన్ తరఫు నుంచి మేము టార్గెట్ EAPCET 2025 స్కోర్ బూస్టర్ సిరీస్ అని మొదలుపెట్టాం. దాంట్లో భాగంగా మనం ఈరోజు ఫిజిక్స్ సంబంధించిన కొన్ని విషయాలు, ఇంపార్టెంట్ టాపిక్ దట్టు ఎస్పెషల్లీ ఎలక్ట్రిసిటీ అండ్ మ్యాగ్నెటిజానికి సంబంధించిన కొన్ని టాపిక్స్ మనం డిస్కస్ చేద్దాం. అంతకన్నా ముందు ఇక్కడ చూడండి, ఏస్ ఆన్లైన్ EAPCET 2025కి టీజీ మరియు తెలంగాణకు సంబంధించి ఇంటర్ ఫస్ట్ ఇయర్ అండ్ సెకండ్ ఇయర్ రెండు కలిపి 3 months కోర్సు మరియు 6 months కోర్సు లాంచ్ చేసిందండి. ప్రీ రికార్డెడ్ లెక్చర్స్ మీ EAPCET ప్రిపరేషన్ కోసం. సో మీరు QR కోడ్ స్కాన్ చేసి మీరు కోర్సును సబ్స్క్రైబ్ చేసుకోవచ్చు. అంతేకాదు ఇక్కడ ఇవన్నీ ఫీచర్స్ ఉన్నాయండి మా కోర్సులో. లెర్న్ ఫ్రమ్ ద ఎక్స్పర్ట్స్ ఫ్యాకల్టీ, బిట్ సైజ్ వీడియోస్, నో లిమిట్ ఆన్ ద వాచ్ టైమ్స్, మీరు ఎన్నిసార్లు అయినా చూసుకోవచ్చు. డీటెయిల్డ్ ఎక్స్ప్లెనేషన్ ఆఫ్ ఈచ్ అండ్ ఎవ్రీ టాపిక్, బేసిక్స్ నుంచి మొదలుపెట్టి అడ్వాన్స్డ్ దాకా. అంతేకాదండి, ఫ్రీ ప్రాక్టీస్ టెస్ట్ సిరీస్ కూడా చాలా ఇంపార్టెంట్. సో మీరు EAPCET ఇక్కడ టెస్ట్ సిరీస్కి ఆన్లైన్ టెస్ట్ సిరీస్, ఫ్రీ ఆన్లైన్ టెస్ట్ సిరీస్కి మీరు రిజిస్టర్ అవ్వచ్చు. టోటల్ నెంబర్ ఆఫ్ టెస్ట్ 8 అండి. సబ్జెక్ట్ వైజ్ టెస్ట్ 3 అండి, మల్టీ సబ్జెక్ట్ వైజ్ టెస్ట్ 3 అండి, ఫుల్ లెంత్ టెస్ట్ 2 అండి. సో ఇది మార్చ్ 1 నుంచి అంటే ఆల్రెడీ స్టార్ట్ అయిపోయింది. మీరు దీనికి సబ్స్క్రైబ్ చేసుకోవాలనుకుంటే ఈ QR కోడ్ని స్కాన్ చేసి మీరు ఎన్రోల్ అవ్వండి. ఓకే, here we're going to start with a new thing, what is called a electric flux and electric flux density, and followed by what is called a Gauss law, which is also extremely important for our exam point of view. Number of times there was a questions. Fine. Anyhow, see here, the electric flux is represented with the symbol psi E, and units are coulombs. And electric flux density is represented with the symbol D, units are coulomb per meter square. Fine. Okay, so let us try to understand what is this electric flux and electric flux density. Now let us take what is called a charge distribution. What it is? Charge distribution. What is the meaning of charge distribution? Whenever I say charge distribution, it may be any charge. It can be a point charge or line charge or surface charge or volume charge. It can be a Q, it can be a point charge, or it can be a line charge, or it can be a surface charge, or it can be a volume charge, or it can be a combination of any two charges. Fine. Suppose if you have a charge distribution like this, there is an electric field around it. So there exists what is called the electric field around this. There is an electric field like this. Electric field lines are like this, like this, like this, and so on from all the sides. Depends on the nature of the charge. Okay, need not something like this. Now what I'll do, I'll going to place the surface here like this. I'll going to place the surface. What kind of surface I am placing? I am placing the open surface. Okay, what kind of surface is this? This is the open surface. Okay, so here the electric field lines are entering from this side, and leaving from this side. Electric field lines are entering from this side and leaving from the other side. Electric field lines are entering from this side and leaving from this side. Okay, fine. So how many number of, what is the total amount of electric field lines crossing this surface is called electric flux, or in other words one can say number of electric field lines crossing through the surface is called electric flux lines. Okay, so these are the electric field lines are crossing this surface. Fine. So the amount of electric field lines, crossing the given surface is called electric flux. Okay, now let us consider the small piece of the area here. Let me consider the small piece of area. It is dA. Okay, and I'll consider the normal direction in this way. This is an open surface. The open surface can have a normal this side or that side, isn't it? For the open surface, normal direction is not uniquely defined. but for the closed surface it is considered always outwards. Okay, area direction is a normal direction. So the amount of electric field lines, the total electric field lines crossing the given surface is called electric flux. The amount of electric field lines crossing the small piece of area is called flux density. It is represented with the D. Units are coulomb per meter square. Clear? So let me define what is called this D. What is this D? D is the electric flux density. So the D is equal to d psi e by dA. Electric flux lines crossing through the small piece of area. Units are coulomb per meter square. You can bring this one other side. So it is d psi e is equal to d dot dA. Clear? It is a scalar quantity. So dot product of these two things. Suppose this is a flux crossing through the small piece of area. If you want to get the overall flux crossing, you need to arrange this small piece of areas in the two dimensions, this way and this way. So what is this psi e? Psi e is equal to surface integral of d dot dA. Correct? Remember, this is just a mathematical expression. It is not conveying any law. What it is saying is, if you know the flux density, this is a flux units are also coulombs. Here it is coulomb per meter square. It is the flux density. So the coulomb per meter square multiplied with the meter square will going to give the flux crossing through that surface. Okay, just it is a mathematical expression. It is not any physical law. So what it is saying, if you know how much flux is crossing through the small piece of area, which is called flux density, by performing the integration over that surface, you can find out the total flux crossing through that surface. Fine. There is a relation here. Let me turn the page. I'll going to explain this relation later when we discuss about what is called polarization. Okay, dielectric polarization. For the time being, just accept this as an expression, some formula here. So there is a relation between D and E. What is this D is? D is called electric flux density. Electric flux density. So this is talking about number of lines. Number of lines per some meter square. Okay. So what is this E? It is called electric field intensity. What is this E is called? Or it is called electric field. Electric field intensity. So it is intensity. It is talking about the strength or magnitude. So it is talking about the strength or magnitude. And one more thing, its units are coulomb per meter square. Its electric field intensity units are Newton per coulomb or simply volt per meter. Later in a future lectures we will going to see. Okay, both are called electric field in general. So D and E. But to be more particular, what is this? D is called electric flux density, E is called electric field intensity. Okay, so you will find the justification of this expression later. For the time being, just accept there is a relation between D and E. So come back to our previous slide here. So what is this electric flux? Number of lines or amount of electric field lines crossing through the given surface is called electric flux. So flux lines crossing through the small piece of area is a flux density. For the flux crossing through this surface, you have to perform the integration, surface integral. Now let me ask one simple question. Is this the total flux which is emanating from the charge? Let me repeat my question. Is this the total flux which is emanating from the charge? Answer is no. This is a flux only crossing through this surface. That is only the part of flux. That is not the total flux which is emanating from the charge. Why? Because let me explain here. Let us say this charge is creating some 100 lines, 1000 lines, let us say. Only 100 lines are crossing through this one. So this is only the part of flux. This is not the total flux which is originating from the charge. Suppose if you wanted to capture the total flux which is emanating from the charge, what you need to do? You should have a surface here. Front side, back side, top side, bottom side, right side, left side, all the sides, so that you can evaluate the flux which is crossing through this one, which is emanating from the charge. So I should have what kind of surface? I should have a closed surface. Clear? And the charge must be inside that closed surface. Okay, so this is only the part of flux. If you wanted to have a total flux, if you wanted to calculate, if you want to capture the total flux which is emanating from the charge, you should have a surface, that side, this side, front side, back side, top side, bottom side, all the sides. That means what kind of surface I should have? Closed surface, and the charge must be inside that closed surface. So this observation so nicely is given by what is called a Gauss law, or simply Gauss's law. Fine. So that is what very important. So for that, to understand the Gauss law only, I have kept some foundation here. Fine. So here is a Gauss law, or it is also called Gauss's law. So what it is saying? The net electric flux coming out of any closed surface is equal to total charge enclosed by that surface. The net electric flux coming out of any closed surface is equal to total charge enclosed. Only 2 points here. Fine. So that is net electric flux is equal to charge enclosed, ENC. Fine. So this is the definition form. Let me show you graphically what I mean to say. Net electric flux is equal to charge enclosed. Fine. Let me show you here what it is saying. Let us take some diagram here. This is a closed surface, something like a balloon. This is something like a balloon, something like a potato, or something like a mango. Okay, it is not a flat one, it is a closed surface, isn't it? How can I convince that it is a closed one? By putting a dots here. What these dots are indicating? It is saying that it is a closed surface. Let us say inside this one there are some charges. Just I am showing the positive charges. It can be a combination of both positive as well as a negative charges. Fine. So this is a closed surface. Inside this one there is a box, there is a volume. On this one there is a surface. Yes, what is the surface here? It is a dA. For the closed surface, normal direction is always outwards. Clear? And how many flux lines crossing through this small piece of area is called flux density. It is D. Units are coulomb per meter square. Okay, we'll come to this point. Let me turn the page here. Let me explain what actually Gauss law is graphically. Yes, let me explain this one graphically. Simple thing. So Gauss law talks about net electric flux. Let me explain this one with the two examples. Okay. So let us say there is a closed surface here. I'll use the same symbol for the closed surface. So how can I convince that it is a closed surface? By putting a dots here. Why I am putting these dots? To create the feel that it is a three-dimensional one. Let me consider the other example. Example number 2. Here is a one more closed surface. Let me put some dots here. Fine. So here it is. Let us say there is a 3 microcoulomb of charge is there outside the closed surface. Here 3 microcoulomb of charge is there inside the closed surface. Just for the example purpose, what I will do, I will say that this 3 microcoulomb of charge is creating the 3 flux lines. If it is inside, the 3 flux lines are like this. Clear? So how many lines are leaving here? What is the net? 3 lines are entering, 3 lines are leaving. So what is the net? 3 minus 3, net is 0. Net flux is 0. How many lines are leaving? 3 lines are leaving. How many lines are entering? No lines are entering. So here it is 3 minus 0, which is equal to 3. Correct? So no doubt each and every charge will be associated with some flux lines. Here there are flux lines are there, but net flux is 0 here. If the charge is outside the closed surface, the net flux contributed by the charge which is outside the closed surface is 0. So it will going to contribute for the net flux only when the charge is inside the closed surface. Now go back to the definition here. The net electric flux coming out of any closed surface is equal to total charge enclosed by that surface. Definition form is the net electric flux is equal to charge enclosed. Fine. So how I can write this one? The flux is nothing but in terms of the flux density. So it is d dot dA. Net is nothing but a closed surface integral, which is equal to charge ENC, charge enclosed. Clear? Fine. Now I have written this one in the vector form, isn't it? How the electric flux can be written? Surface integral of d dot dA. Why did I said here in the law it is a net. That is the reason why we have got a closed surface. Fine. So what I will do here, instead of this, I will take this charge enclosed within this one as a volume charge. So because this is a volume, so according to the charge you need to react. Suppose if it is a line charge, if it is a discrete charge, you need to add the individual charges q1 plus q2 plus q3. Suppose if it is a line charge inside the closed surface, you have to perform the line integral to get the total charge. If it is a surface charge, surface integral. If it is a volume charge, volume integral. Fine. So as I have considered the volume here, so I am going to describe this charge as a volume charge, rho v coulomb per meter cube. Fine. So let me turn the page here. So Gauss law for the volume charge. Suppose if the charge enclosed is volume charge, then how to handle this one? What is the Gauss law, guys? So the Gauss law is net electric flux is equal to charge enclosed, ENC. Fine. So how this net electric flux can be written? It is a surface integral of d dot dA. Net in the sense it is a closed surface integral, which is equal to volume integral of rho v into dV. As you can see the integrals on both sides, this is called Gauss law in the integral form. Gauss's law or Gauss law in the integral form. Okay. So I will going to convert this one into the other form, what is called a differential form, or it is also called point form. Okay, guys. So from the divergence theorem, what we can do? There are two theorems. One is a divergence theorem, other one is a Stokes theorem. So in the divergence theorem, we can relate the relation between the closed surface integral and volume integral. By using the Stokes theorem, we can relate closed line integral and surface integral. Fine. So here there is a closed surface integral. From the divergence theorem, what can be written? A closed surface integral of d dot dA, which is equal to volume integral of divergence of d into dV. Okay, which is equal to volume integral of rho v into dV. You can equate these two things. So you can make a comparison here. So at the place of divergence of d, you are having the rho v. Fine. So what you will going to get? On comparison, divergence of D is equal to rho V. Clear? So this is called Gauss law. What this is? This is a Gauss's law in, or simply Gauss law in point or differential form. Point or differential form. Fine. Let me turn the page here. Let me summarize what actually you need to remember for your exam. Note, extremely important. Gauss law is very, very important. Number of times questions was seen in all your previous papers. GATE, ESC, state service exams, even in the SSC JE, RRB JE also. Fine. So, what is the definition form? All these three forms are important. So, the net electric flux is equal to charge enclosed. This is the definition form. Yes, the other one is the integral form. What is the integral form? Closed surface integral of d dot dA, which is equal to volume integral of rho v into dV. Third one is divergence of D is equal to rho v. Clear? So, a definition form, from the definition form only we have obtained the second and third one. What is the second form is saying? If you take any closed surface, net electric flux from this closed surface is equal to charge inside this. This is a volume. Inside this one, it is, as it is a volume, it will going to have a volume charge. To get the total charge, you have to perform the volume integral. What is this divergence of D? If you remember, it is a divergence. What is the divergence definition? It is a net flow from the small piece of a box. Net flow from the small piece of a box. In this small piece, what is the charge? Charge in the small box is nothing but a volume charge. So, this is for any arbitrary closed surface. This is at a point, or it is also called differential form. So, the law will going to remain the same whether you are defining for any closed surface or for the small piece of a box, the law remains the same. So, this is a definition form. Okay. In the definition form, it can be any charge. It can be a discrete charge, line charge, surface charge, volume charge. So, we have done for the volume charge. Clear, guys? Okay. So, very, very important. I'll give the 5-star rating to this. Fine. So, on the first form, 1 mark questions are expected. On the second and third form, 2 marks questions are expected. Fine. So, now what we'll going to do in the next session, we'll going to take the wide varieties of questions which are related to this Gauss law.